Okay guys, so we are picking up on yesterday's notes. So let's just kind of review what we had already gotten through. So remember that we'd graphed the region, we'd found the x-intercepts, which were 0 and -2, and that gave us the endpoints here and here. Then remember that we defined our base as top minus bottom. Remember that it was 0 minus x squared plus 2x because 0 was the x-axis, that's the top, and then the x squared function was the bottom. Okay? So from there, we need to set up our next shape, which is an isosceles right triangle. So an isosceles right triangle, isosceles means that two of the sides are the same. Right triangle means that you have a right angle. But look how it says we want the hypotenuse as the base. So what that means is that when I draw my right triangle, the hypotenuse, if you were to do like these are the two legs that match each other, and then this is the third side. So think about, this is my 90-degree angle pointing up, and then these are my two sides or angles that match. Okay? So remember that in order for me to find area of a triangle, I need to do 1/2 base times height. Now remember that it doesn't matter what type of triangle it is. If it's a triangle, that is how you find the area. So what I need to figure out is what I can call the height, because this height has to be substituted out to be in terms of B stuff. So I'm going to draw my height then here. And then I'm going to use the same strategy that I use for equilateral triangles on the other page. I'm going to only look at half of the triangle at a time. So I'm going to mainly just focus on that yellow half. So I'm going to redraw it down here. Okay, so remember that if this is a 90, then these are both 45-degree angles. So when I cut my triangle in half, this one is still 45. Now think about this triangle, or this angle on top was a 90-degree angle. So if I cut my 90-degree angle in half, now that's a 45. So those are my two matching sides, and then notice that this side here, this is my H. So if these two sides match, okay, well now that's my hypotenuse, and these two sides have to match. So now think about, if this side here is the base, okay, which is all the way across the region, then this side down here is base over 2. And remember that if we said this is a 45-degree angle, then this 45 and that 45 have to match each other, which means really my height is equal to my base over 2. So I'm going to rewrite this here as 1/2 base over 2. Okay, and that's by property of special right triangles, that anytime you have a 45-degree angle, these match. So one more time, if I cover that up and I see my little baby triangle, these sides have to match because those are the sides that are not the right angle. Okay? So my area equals 1/2 times 1/2 is 1/4 B squared. And then remember, in order for me to get volume if I have area, it's the integral of 1/4 B squared dx. And then remember up here we had found our B earlier. It's negative x squared minus 2x, so I'm going to fill that into my parentheses here. Negative x squared minus 2x. Now remember that my endpoints are going to be the same as they were previously for the region. Remember we said that it was from -2 to 2. I'm sorry, -2 to 0. So those are going to be the endpoints on my integral. So -2 here, 0 here. And that would be your answer. Okay? So next one we want is a semicircle. So look at part E. Okay, for a semicircle, remember that's half of a circle. Okay, here's my base line across the bottom. So the area of a semicircle is 1/2 pi r squared. But then remember that my r can only be halfway across the circle. So if this is my r right here, well then think about, if the whole thing is the base, then my r is just going to be the base over 2. Because instead of being all the way across, it's only halfway across. That's what I'm going to substitute then here. So it's going to be 1/2 pi base over 2 squared, where base over 2 is standing for my radius because it's halfway across. Okay, then from there, I have a half pi, and then I have to square the top, that's a b squared. I have to square the bottom, that's a 4. And then I'm going to combine all of this constant junk together. So if it's a half times pi, that's really pi halves. And then times 4 on the bottom is going to be pi over 8 b squared. And then I'm ready to set up my integral. Negative 2 to 0. And then remember, you have two choices. You can put the pi eighths here or on the outside. I'm going to put it on the outside. So pi over 8. And then my b is negative x squared minus 2x quantity squared dx. Okay? All right, look at the next one. We want a semi-ellipse. Remember that an ellipse is the same as an oval. So I'm going to draw my ellipse here. Now remember that I'm only drawing half of it because it's a semi-ellipse. So remember that the area for a semi-ellipse is pi jk, and then a half in the front. So a half pi jk. Then remember that j is going to be the radius measurement one direction, and then k is going to be the radius measurement going the other direction. Okay? So now notice that it tells me that my ellipses are always going to have a height of 6. So that means that this side is 6. This side I'm going to call j. Now think about it. If the entire distance across the semi-ellipse is the base, well then j is just going to be the base over 2. And so if j is the base over 2, then I'm going to plug that into my equation here. So I'm going to have area equals 1/2 pi. My j is a base over 2. And then notice that my k is this distance here, which we said is 6. So a half times a half is a fourth. Multiply that by 6. I have 6/4 pi. And then I just have 1b. So notice that the half and the half came into the fourth. The 6 stayed on top and the pi stayed right there. So that's my equation. Now if you want to reduce that, you totally can. 3/2 pi and then a b. Now remember, this is for area. So if I want to go from area to volume, then I do v equals the integral of that. 3 pi halves in the front, and then b on the inside, negative x squared minus 2x dx, negative 2 to 0. And then from there, remember, you would just type that into your calculator, boom, you'd be done. Okay? Go ahead and turn the page, please. Set up that next region. We are almost done with your notes for today. One left. Okay, I have negative 2x squared plus 9 and x squared minus 3. So let's set up our region first. Negative 2x squared plus 9 is going to start at 9. It's going to open down. Then x squared minus 3 is going to start at negative 3. That's the y-intercept, and it's going to open up. So we'll say maybe negative 3 is here. And then it opens up. So here's my graph. Remember, the next thing that I need to do is I need to find my endpoints. My endpoints are going to be found by setting my equations equal to each other. So I'm going to do that over here kind of on the left side. I'm going to let my negative 2x squared plus 9 be equal to my x squared minus 3. Okay, this is to find my intersections. Okay, so first thing I'm going to do is add 2x squared across. So I have 9 equals x squared plus 2x squared is 3x squared. Then from here I'm going to take my minus 3 and add that across. So 9 plus 3 gives me 12. Okay, hopefully you can see that my next step here is going to be to divide by 3. Okay, 12 divided by 3 gives me 4. And then if x squared equals 4, then I can square root. X has to be plus or minus 2. Which means that this left side over here is my negative 2. This right side over here is my positive 2. Okay, after I set up my region, all of that you should have already known how to do. Then I'm going to draw in my base, or we'll say maybe the distance across the base. And notice that it says here I'm still taking the base perpendicular to the x-axis. Okay? Then my base is going to be top minus bottom. So I would look to see which of my functions is on top, which of my functions is on bottom of the region. So the top one is the one with the negative 2x squared plus 9, and the bottom of the region is x squared minus 3. Okay? Then from there, I'm ready to combine like terms. Okay, just to try to simplify it so that my base isn't so complicated, knowing that I'm going to have to rewrite it several times. Now, hopefully, okay, you have a little warning going off, okay, that you got to have parentheses around that. And remember, that matters in how you combine like terms. So I'd have negative 2x squared minus an x squared. Negative 2 minus x squared is a negative 3x squared. But then if this is 9 minus negative 3, really that's 9 plus 3, which is plus 12. So that's going to be my base. And remember, it doesn't matter what shape it is, that's the base regardless. Okay, from here, my first thing is a square. So I'd have area equals base squared. Boom, that's the base, and you're done. Negative 3x squared plus 12 squared. My endpoints were negative 2 to 2. So those are the boundaries of my integral. Every time I should have put a dx, so if I missed a dx on one of those, just make sure that should be there. That would have been a mistake if I left it off. Okay, next one, it says I want a rectangle. Rectangle's base times height, but then look what it says. I want the height to be modeled by 2x plus 1. Okay, well then that's going to be base times 2x plus 1. And I'm just going to take that height and I'm going to sub it into my equation. Now, when I set up my volume, remember that I already have a substitute for b. b is this. So I'd have negative 3x squared plus 12. That's standing in for my b here. And then times my height, which is 2x plus 1. Then remember that my endpoints are the endpoints of my region, negative 2 till 2. Okay, next one is a semicircle. So sketch a semicircle for me. Okay, remember that all the way across is the base, so if I want the radius only, the radius would be the base over 2. And then I would set up my area formula for that. Remember that area of a semicircle is a half pi r squared, but now I know that my r is really a b over 2. So that's going to be a half pi b over 2 squared. And then remember that I have to square both the b and the 2 separately. So really this is a half pi b squared over 4, because I have to square the b and the 2 on the bottom. Then from there, the 2 and the 4 multiplied together is going to give me a pi over 8 b squared. And that's the formula that I'm going to use to write my volume. So it would be v equals pi eighths in the front, and then the integral from negative 2 to 2 of my base, which is top minus bottom, negative 3x squared plus 12. Okay? Semi-ellipses. Okay, let's do our semi-ellipse. So remember, the only real difference, okay, from a circle to a semi-ellipse is that instead of both of your radius measurements being the same, they're different. You have one that goes across, you have one that goes up and down. So notice that it tells me here that my height is 4. That means that I can just sub in this side is 4, but I still need to know this side. Now remember, all the way across the bottom is the base. So that means that the blue radius halfway across that would be b over 2. So then area equals 1/2 pi jk, where my j is this distance, b over 2, and then my k is this distance, which it told me was 4. Now notice that when I combine like terms there, I'm going to have a half times a half is pi over 4 times b. But then since I have another 4 there in the back, my 4 and my 4 cross out. So really my equation for this one is pretty easy. It's just going to be pi b. Okay, that's supposed to be an arrow. I don't know why it looks so ugly. Okay. So then from there, I'm going to do volume equals pi times the integral of the base, negative 3x squared plus 12 dx, and then from negative 2 to 2. And notice I'm not putting a squared or anything on that because there's not a squared in my area formula, which was pi b. 2 more left. Let's do this one first. So I have a triangle. Okay, area of a triangle is 1/2 base times height. And then notice what it tells me, just like we did on part B. It tells me that the height is modeled by a function 3x. Well, then I'm just going to plug that in. So I'll have area equals 1/2 base, and then for my height, I'm going to plug in a 3x. So my volume equals the integral 1/2. My base is negative 3x squared plus 12, just like it was previously. And then I'm going to multiply by 3x. Okay. Now, my endpoints there would still be negative 2 to 2. But let's talk about if we wanted to pull the constants out of that. Remember that I can pull out the half, but really I can also pull out this 3. So if I pulled out both of those, I would have a 3 over 2 in the front. And then I'd have a negative 3x squared plus 12, and then an x dx. So remember, I can pull the 3 out, I cannot pull the x out. So the x would have to stay even if you pull the 3 out. Okay? All right, last one, part C. I want an equilateral triangle. Remember that an equilateral triangle is also equiangular. Okay, that is also equiangular. So if the sides are the same, then all of the angles are the same. Now remember, all of them have to add up to 180 degrees. So if I divide that by 3, that means that each of these angles is 60. So 60, 60, 60. Now, to find the area of a triangle, it's 1/2 base times height. So I see that my base is here, all the way across. But my height is going to be this vertical distance. And then remember, the way that we handled that was we divided the triangle into 2 sides. And then we used properties of special right triangles to rewrite the height in terms of the base. So let's look at our little halvesy triangle here. Okay, remember that if this is the base, then this side is the base. And this side is the base as well. We're just not really looking at that side. Remember, we're kind of like pretending like that side isn't there. So this side is the base because it was equilateral. So then that means that this side has to be base over 2 because it's the short side. And if this side is base over 2, then this side is base over 2 root 3. Because those are the sides of your special right triangle. Now also let me address, we know that this side is 60. Remember that we know that this side is 30 because the whole thing was 60. So when I cut it in half, that's why that side is only worth 30 degrees because I cut it in half. So let's rewrite our area equation, 1/2 base, and then when I get to my height, I'm going to use this substitute right here, that my height is the same as b over 2 root 3. And then remember, I collect all the constants together to make like one big mega constant so that I can rewrite my integral. So a half times a 2 on the bottom is a 1/4. And then a root 3 on the top is a root 3/4, and then a b squared. And then remember that if that's area, then volume is the integral of that. So 3/4 here, my b was negative 3x squared plus 12 squared dx, negative 2 to 2. Okay? Now also keep in mind, the only reason I didn't put the root 3 over 4 in front was because I didn't leave enough space. But you could easily have put that here, and that would have been totally fine. Okay, so pull out homework 3. I'm leaving this up with extra copies of these just in case, but you should already have it from today. So we are going to do number 2. Okay, so if you will, look at number 2. So number 2 says that we want the base of a solid to be a region in the first quadrant, okay, modeled by the line y equals 2 and y equals square root x. So let's sketch what that looks like. So y equals 2 would be up here, and then y equals square root x starts at the origin and curves up. Now the first quadrant thing is important because remember, that tells me where to shade. These only cross once, so I know I'm going to stop the region there, but first quadrant tells me that I'm not going to start until 0. Now, that second ordered pair you're going to have to find. Remember, you'll find it by setting your equations equal. So if I have y equals 2 and square root x, then I would let square root x equal 2 and then solve. So square, square, x equals 4. And in case you're wondering, that was to find the intersection. I didn't label it, but hopefully you knew that. So this is x equals 4. This other side is x equals 0. Okay, after I set up my region and I find my endpoints, I need to draw in my base. Remember that my base is perpendicular to the x-axis, perpendicular to the x-axis. So I'm drawing it in this way. Now remember that when I draw in my thing, it needs to be top minus bottom. So I need to look for what's on the top minus what's on the bottom. So my top function that I'm touching is y equals 2. My bottom function that I'm touching is square root x. So b equals 2 minus square root x. And that is the distance across the base that you're going to use regardless of whatever shape they tell you to do. So part B says to set up the volume of the solid if they're squares. So remember that the area of a square is b squared. Then remember that that means that the volume is the integral of b squared, where b is 2 minus square root x squared dx. Also remember that your endpoints need to be the endpoints of the region. So I have 0 on this side, I have 4 on this side, so 0 to 4. Okay? Go down to the next part, part C. Says that they're isosceles right triangles, but your leg is adjacent to the region. So that means that my isosceles right triangle, these two sides match. Okay, now remember, this is my base. Well, if it's isosceles, that means that 2 of my sides are equal. 2 sides are equal. And if it's a right triangle, specifically, that means that this base and this height are equal. So when I set up my equation over here, it's area equals 1/2 base times height. I'm going to replace, I know that my height is really also my base because these have to match each other. So I can rewrite that as 1/2 base squared. And then from there, I would set up my volume. So remember, if that's area, volume is the integral of that. So I'm going to put my half on the outside integral. I'm going from 0 to 4. And then my base squared would be 2 minus square root x squared dx. Okay, and that would be your answer. Now, I do want to point out to you that in your homework, there are some questions that say perpendicular to the y-axis. You are not going to do those. Okay, you need the notes for tomorrow. We haven't covered that yet. So if it says perpendicular to the y-axis, you have to wait. Turn the page, we'll do one more. Let's do number 6. Okay, so first thing I want to point out to you is that your calculator is required. It says that up here at the top. So make sure that when you're sketching these regions and stuff, you should be using your calculator to do that. So I'm going to go into my calculator. I'm going to type in the 2 equations. Go ahead and do that for me now. So inverse tan x and y equals 3. Okay, notice that's not tan x, that's inverse tan x. So when I put that into my calculator, I want to make sure I do second tan, okay, and then x. Now notice that they gave you another line. They gave you x equals 1. Since that's vertical, I can't put that into my calculator. Or actually, maybe you can. I just don't know how, so I'm not going to. Okay, so there's inverse tan. There's y equals 3. Now, eventually, are these graphs going to touch? Yes, probably. Do I care if they touch? No. Okay, this is y. So there's my inverse tan x. And then y equals 3 was up here. Remember that as long as I know the region that I'm integrating on, it really doesn't matter if they cross or not. So if you look at your equation, it says I want to be in the first quadrant. That tells me I need to start at 0. And then they told me x equals 1. Well, that's where I'm going to stop shading. That's my other boundary. So I'm going to shade from 0 until, we'll say 1 is right there. So this is x equals 0. This is x equals 1. Okay? So let's read through the important stuff. So we want to be perpendicular to the x-axis. Okay, perpendicular to the x-axis tells me that I need to stay vertical, like this, which means that my equation or my base is going to run top minus bottom. So base is going to equal the top function, which is 3, minus the bottom function, which is inverse tan x. Then from there, I'm going to write the equation for the shape that they gave me. So it says, for this solid, each cross-section perpendicular to the x-axis is a square. And I'd be like, okay, well, if I want a square, area of a square is b squared. And then, oh snap, we know what our b is. It's 3 minus inverse tan x. So volume equals the integral, 3 minus inverse tan x squared dx. Then remember that my endpoints are from 0 till 1. Okay? Now, let's talk about how to put this in the calculator. I would like for you to use the shortcuts just because they do make you faster and they will remove a lot of the mistakes that y'all make with forgetting parentheses. So this is my y2 and this is my y1. So when I type this into the calculator, okay, I'll put my calculator up here, but it's going to be math 9. Okay, then I'm going to go from 0 to 1. Hopefully you can see that. And then I'm going to come in here. I'm going to put parentheses y2 minus y1 parentheses. Aw, dang. I wasn't looking at my calculator. Okay, math 9, 0 to 1. And then it'd be parentheses y2 minus y1 squared dx. So that way you're subtracting 3 minus inverse tan, but remember they're just already typed in here for me. Okay, so then I just push enter on that, boom, you get your answer. 6.6123, which is answer choice B. Okay, now look ahead for me to that last page, please, just real quick. Okay, and what you should notice is that for all of this last page, it says perpendicular to the y-axis, perpendicular to the y-axis, perpendicular to the y-axis. And then this last one says perpendicular to the y-axis. So if that is the case, you are not doing those yet. All of those integrals are going to be dy, which we haven't covered yet. Okay, so just leave that last page off. You're just working on the first problems, okay? So you can do it. Good luck, and I'll see you tomorrow. We'll cover the dy integrals then.